At this point, we've covered all of our adult brain structures or brain regions. So we've covered those cerebral hemispheres. We've covered the diencephalon, which is composed of the thalamus, the hypothalamus, and the epithalamus. We've covered the brainstem, which is composed of the midbrain, the pons, and the medulla oblongata. And we've covered the cerebellum. All of those different brain regions or brain structures are discrete structures. But in addition to those discrete structures, we also have what are called functional brain systems. Functional brain systems are going to be these networks of neurons that come from all different parts of the brain. So functional brain systems are networks of neurons that cross many different structures in the brain. There are two functional brain systems. There's the limbic system and reticular formation. So our first functional brain system is the limbic system. The limbic system is going to be a network of neurons that crosses parts of the cerebral hemispheres and the diencephalon and functions as our emotional brain. So the limbic system is going to be a network of neurons that crosses parts of our cerebral hemispheres and diencephalon and functions as our emotional brain. In other words, the limbic system is going to assign emotional impact to things that we see, things that we smell, memories, and so on. So the limbic system functions as our emotional brain, which allows us to react emotionally to things that we see, things that we hear, things that we smell, memories, and so on. You'll see at the bottom here that I do have a list of some of the structures within the cerebral hemispheres and the diencephalon that function as part of the limbic system. Some of those structures you've heard of before, such as the thalamus and the hypothalamus. Others you may not have heard of before, such as the amygdaloid body or the parahippocampus gyrus. You are not expected to know the specific names of those structures. Okay, so you just need to know that the limbic system is a network of neurons that crosses parts of the cerebral hemispheres and the diencephalon. The second functional brain system is reticular formation. So the reticular formation is going to be this cluster of loose neurons at the central core of our brainstem. So the reticular formation is going to extend down through the core of the brainstem. So from the midbrain to the pons to the medulla oblongata. And it's composed of loosely clustered neurons. The reticular formation is composed of these loosely clustered neurons that are known as the reticular activating system. The reticular activating system is going to be a group of neurons that's going to receive sensory impulses from all over the body. So all of our sensory information, so all of our ascending general sensory information is going to come in. It's going to synapse with this group of neurons at the central core of the brainstem. And then this group of neurons here, the reticular activating system, is then going to send that sensory input to the cerebral cortex to arouse the cerebral cortex and keep it alert. So all of our ascending general sensory tracts, so all of the sensory information coming to our brain, is going to synapse with neurons in the reticular activating system. Those neurons, once again, are located at the central core of your brainstem. So all the sensory information is going to synapse with the reticular activating system. And then the reticular activating system is then going to relay all of the sensory impulses to the appropriate regions of the cerebral cortex. This allows for the cerebral cortex to stay aroused or alert. In addition to keeping the cerebral cortex alert, the reticular activating system also functions to filter out any unnecessary or unimportant sensory information. So the reticular activating system also functions to filter out about 99% of all of our sensory stimuli. So only about 1% of all of our sensory stimuli actually reaches the cerebral cortex. This is extremely important because if this filtering didn't occur, we would essentially be driven crazy by sensory overload. So it's really important that our reticular activating system is filtering out any unnecessary or unimportant sensory information so that only the most important information is being delivered to that cerebral cortex. So some examples of sensory information that might be filtered out might be things like you feeling that you have shoes on, okay? So you might be having sensory information being sent from your feet telling your brain like, hey, you're wearing shoes. Shoes are touching your skin. But that information is irrelevant as you're going on throughout your day. But if you were to lose your shoe, you would then have that sensory information being delivered to that cerebral cortex. So that would then be considered important information. Okay, so lots of sensory information is going to be filtered out so that only the most important stimuli are being delivered to that cerebral cortex. So a great example of our reticular formation's function is an example of when you're driving when you're drowsy. So let's say that you're on your way home for Christmas break, and you've got a really long 10-hour drive. You're starting to feel a little bit tired, okay? And you're like, oh no, I need to stay awake for this 10-hour drive. So what do? You immediately start to increase the amount of sensory stimuli being sent to your brain. So you might start to roll the window down, let some of that cold air in. You might start drinking a really cold drink. You might start turning the radio up, right? So you're trying to increase the sensory stimuli being sent to the cerebral cortex so that in turn you're increasing the activation of your cerebral cortex to keep you alert and keep you awake.